Welcome to Week 7 of Hazardous Waste Treatment and Disposal. This week we will discuss risk assessment processes and management approaches for dealing with hazardous wastes. The assessment of health effects on workers, the general public, and the environment is often required in hazardous waste management. Potential hazards to public health and the environment are often evaluated using a multi-step risk assessment process. The ultimate goal in using risk assessment is to provide a quantitative basis for making decisions involving hazardous waste treatment, remediation, and disposal options, waste minimization, and siting new facilities. Risk, as it applies to hazardous waste, may be defined as the chance of encountering the potential adverse effects of human or ecological exposures to environmental hazards. In general terms, risk is the probability of harm or loss, which may also be considered as a product of probability and the severity of the consequences. Something to remember is that risk is inherent in all forms of life. Natural disasters such as hurricanes, earthquakes, tornadoes, and landslides present a risk of injury or death to any living thing. Human-caused risks also occur at varying levels of severity, including car accidents, plane crashes, and railroad derailments. Some specific definitions apply to risk assessment in hazardous waste management. Background risk in hazardous waste management is the risk to which a population is exposed without considering hazardous chemicals. Total risk is the background risk plus the incremental risk from some other event. Hazard is a descriptive term that characterizes the intrinsic capability of a waste to cause harm. Hazard may be thought of as a source of risk and is a function of the persistence, mobility, and toxicity of the contaminants. 4 steps have been defined by the EPA and the National Academy of Sciences for the assessment of risk from hazardous waste. The first step is hazard identification, which refers to the chemicals present at the site or facility and their characteristics. The second step is exposure assessment, which evaluates the potential transport of the chemicals to receptors and levels of intake. The third step is toxicity assessment, which includes the determination of numerical indices of toxicity. The fourth step is risk characterization, which involves the determination of a number that expresses risk. Although much of the emphasis in hazardous waste management has been in protecting public health, the key provisions in RCRA and CERCLA refer to protecting public health and the environment. Therefore, assessing the risk of hazardous waste to the environment is also important. Ecological risk assessments are conducted in a manner similar to human health risk assessments through an identical 4-step process. Risk assessment alone provides a quantitative value of potential hazards from hazardous waste sites and facilities. However, the risk evaluation is usually carried further through risk management. Risk management is the decision-making process that is based on the quantitative value obtained from risk assessment models, coupled with insight, experience, and judgment. Over the past 20 years, a hierarchy of priorities has been developed to manage hazardous wastes. Based on the costs, threats to public health and the environment, and potential liability of some disposal technologies, the highest priority is waste minimization and pollution prevention to decrease the volume, mass, and toxicity of hazardous wastes that are generated. Not all waste can be minimized or recycled. Therefore, the second tier of waste management is treatment, with emphasis on destruction of the hazardous chemicals. The selection of treatment processes becomes somewhat complex and is a function of the waste properties and dynamics, their concentrations, and the complexity of the matrix. Some of the more common treatment processes and operations include air stripping, granular activated carbon, traditional biological processes, advanced oxidation processes, metals precipitation, ion exchange, and thermal processes like incineration. The final option in the management of hazardous waste is disposal. This disposal is the long-term containment with no treatment. Landfill disposal is the most common method of disposal. When RCRA was first promulgated in 1980, hazardous waste landfills were of low quality from both technical and management perspectives. The consensus among scientists and engineers was that all of hazardous waste landfills managed under RCRA would eventually leak and become the next generation of Superfund sites. Landfill technology has progressed significantly since 1980, and although not a perfect option, hazardous waste landfills represent a satisfactory means for the disposal of non-minimizable and untreatable hazardous wastes. Landfills are now designed to contain waste while minimizing releases to the environment.